All right, this is going to be our video for Unit 2, Day 3 in Algebra 1. We were talking about slope-intercept form, and we're going to start by identifying what that is and do some examples on how to graph and how to use slope-intercept form. But first, I want you to make sure you have this page that you picked up in class, because I've provided graph paper for you on one side and lines on the other side. The back of the page looks like this, so we can do some other examples just with lines if we need to. But I do want to make sure that you have this copied down. So we want to start always by making sure you have the correct heading copied down, and we're starting with this information. Okay, we're going to start by identifying what slope-intercept form actually is. So when we have an equation in slope-intercept form, that means it looks like this, where y is all by itself, and we have the other information with an x value on the other side. M and b are going to be replaced with numbers. Now you might remember that m stands for slope. Remember, that's the rise over run of the line. But before we get to where we can use slope, we have to have a starting point. And so for this form of our equation, we're going to identify the y-intercept. And that's what this b value is. It's the y-intercept, I-N-T-E-R-C-E-P-T. And this number tells us where the line that we're representing with this equation crosses our y-axis. Okay, and it's actually the y value of that point. Okay, the x coordinate of that point will always be 0, and then we'll have whatever number that is for that. And so here's an example that you might see. Okay. You might have something like this, y equals 1/2 x minus 2. Okay, so we're going to do our example 1 graph here. Okay, I'm going to make my graph, and I'm going to pause my video so I can copy that down, so I can put that there for you to copy down. If at any point you need to pause the video to get it copied down, go ahead and do so. Okay, and so what you see here is I've given you a graph, and this is the equation of my line I'm using, y equals 1/2 x minus 2, and this is the line that would give us, y equals 1/2 x minus 2. I've written it in above the line so you can see it. What this tells me is that the y-intercept of my graph, of my line, is -2. So this line is going to cross my y-axis at -2. And then my rise over run is up 1 over 2, to the right 2. This is a positive slope, so it goes up and to the right. So if I go up 1 to the right 2, puts me at a point there. If I do that again, puts me at another point, and so on and so forth. And so that's how we might graph a line given that information. We start with the y-intercept, and then we do our rise over run to find a second, third, or even fourth point. And we connect them with a straight line, putting arrows at both ends. So in our next example, example 2, what you might be given is the equation of a line and told to graph it. So I'm going to give you another equation. Y equals 3x plus 1. So I want to graph that line. Well, the first thing I need to do is make an x and a y axis. There's my y-axis. There's my x-axis. Okay, this is about the middle 1/3 of the page, somewhere in there. Make it about the same size as I have. Label your axes, label your origin, 0, 0 is in the middle there. And now we're going to plot these coordinates, or we're going to use this b value as our starting set of coordinates. That means my line is going to cross the y-axis at +1, which is right there. But this slope is just a whole number. Anytime you see the slope written as a whole number, you need to turn it into a fraction, which to turn a whole number into a fraction, remember we just put it over the number 1. So this means I'm going to rise 3 and run 1 to the right. So I'm going to go up 1, 2, 3 spaces, then 1 space to the right. And if I did that again, I would be off the graph, but you could get a better fit for your line if you needed to. Then we take a straight edge, line those up, and graph the line. And that is how we graph a line if we're given an equation. Okay, here's the here's the next example we should have on our page. Okay, you might be asked to write the equation if you're given a line. Now, I haven't given you the line yet. I'm going to in a minute. But this is the point where you'll want to pause the video and copy this down. When you have notes to turn in at the end of this unit, you will want yours to look like mine look in the videos. So I might give you an equation, or sorry, a line like this. So your line might look like this. Now you need to be able to mark this line correctly on your notes. So notice that it goes through the x-axis here, the second point to the left, and goes through the y-axis at the third one below the origin. Just line those up and draw your line. And so that actually helps us identify part of what we need for our slope and our intercept. Because if I'm using slope-intercept form of a line, I need the slope of the line and the y-intercept. This is what we're going to start with, the y-intercept. Where does this line cross the y-axis? That'd be the point -3 on the y-axis. And where do I get my slope? Well, that's rise over run. I've told you to always go from left to right when counting rise over run. So we're going to actually count that out from this x-intercept, where it crosses the x-axis, to this y-intercept. We would have to go down 3. That would be a -3. And to the right, 2, +2. That means my rise over run is -3/2. And I can leave that fraction written that way. That is an improper fraction, but it is simplified. I cannot reduce that at all. So if I'm going to write my equation in slope-intercept form, I'm just going to plug these numbers in. For y equals mx, I'm going to replace m with -3/2. Don't forget to write your x. Plus b is a -3. Rather than writing plus -3, like this, I'll kind of go out to the side. Rather than writing plus -3 like that, I'm just going to change it to -3. Because that's the easiest, most simple way to write this equation. All right, let's go ahead and turn this page to the back. All right, we will do some other examples now to show you what you need to know about this lesson about using slope-intercept form. Slope-intercept form is not the only form we could write equations in. They could have several different equations that all mean the same line, and so we're just focusing on slope-intercept form in this unit, or in this lesson rather. So I'm going to give you some examples where we have equations written but in different forms, and we have to change those into slope-intercept form. So here's an example. Okay, once you've copied this down, you can continue to play the video. A pause would be an option here if you need to have extra time. But I want you to write the slope-intercept form of this equation if we're given this. This is not slope-intercept form. Remember, slope-intercept form is y equals mx plus b. So all we have to do is get y by itself and make sure there are no parentheses. So that's the first two things we have to do. I actually want to work with the parentheses first. You can remember from PEMDAS, we like to work with parentheses first. How do you think we would get rid of the parentheses here? If you were thinking distribute, that's correct. We want to distribute 2 to the x and 2 to the -1 first. It's going to give me y plus 3 equals 2x minus 2. Now we need to get y by itself to be completely in slope-intercept form. So I want to get rid of the plus 3 by subtracting 3. And in order to subtract 3 here, I have to subtract 3 on the other side of the equal sign. I don't want to put it underneath the 2x because it's not a like term with 2x. I want to subtract 3 from the -2. On this side they cancel. So y is finally by itself. Y equals 2x still, but this -2 or -2 minus another 3 should be -5. And that is the y-intercept, or sorry, slope-intercept form of the same equation. Both of these equations, if I were to graph them, would give me the same line. All right, the hardest thing we're going to have to do in this lesson is to write an equation in slope-intercept form, but I'm not giving you another equation, and I'm not giving you another graph. All I'm going to give you are 2 points that would be on the line. So it might look like this. In this example, I want you to write the equation in slope-intercept form, so we're still using our y equals mx plus b. of a line that passes through these points. And what that means is, on a graph, I would have these 2 points and a line connecting them. That's the line I want to use. So don't be confused by the word through here. It just means these 2 ordered pairs make the line for us. And we want to write the equation of that line. Neither of these points are the y-intercept. And so to do this, we're going to kind of need to do a lot of work. The first thing we want to do here is to actually find the slope. Because if I give you 2 ordered pairs, we can always use the slope formula back from day 1 to find those ordered pairs, or to find the slope using those ordered pairs. That means you need to make sure we classify this first ordered pair as x1, y1, and the second ordered pair is x2, y2. So we're going to plug in those numbers. For the top, I'm going to do the second y-coordinate, y2, -8, minus the first y-coordinate, y1, -6. Minus -6 here, this minus and that negative, are going to turn that into a plus positive. This -8 stays a negative though. I'll fix that in a minute. Then I want to do x2, which is 3, minus x1, which is just 2. So when I change this to plus positive, it's really just -8 plus 6. -8 plus 6 gives me -2 over 3 minus 2 is just 1. -2 over 1 simplifies to just -2. So that's my slope. So I know part of my slope-intercept form of my line. I know I'm going to have y equals -2x plus some b value. That's what I have to find now. That is what I'm looking for. Okay? I need to figure out what b is to complete this equation. It's like I'm looking for a missing puzzle piece. In order to find b, we're going to go back and use one or the other of these ordered pairs for x and y and plug them in and just solve for that missing variable b. Okay? So I'm going to choose the first one. It doesn't really matter which one we choose. I'm just going to choose the first one. Okay? I'm going to plug in my numbers here. So instead of -2x, it's going to be -2 times 2 from that x-coordinate, plus b, and then y equals at the front is now -6 equals. Okay? So we're going to multiply here. -2 times 2 is -4. To solve for b now, we add 4 to both sides. Cancels out there, and I found out now that b equals -2, because -6 plus 4 is -2. So that can go back into my equation there for b. So my final answer here is y equals -2x for my slope, -2, plus -2, or -2 for my b value. And it's just a coincidence that both of these worked out to be -2 this time. Okay? We'll do a little bit more work in class to make sure you fully understand this, but that does conclude this lesson video.